Good morning to all of you. Today we are going to see the topic of equilibrium of rigid bodies. The equilibrium means the net effect of all the force act on the body is equal to 0, or the summation of all the force act on the body is equal to 0. In proper way, in equilibrium, the body is initially at rest. It always at rest, or the body is moving with constant velocity. It always moving with the same velocity. That's the equilibrium. Rigid bodies. So rigid body means non-deformable body. In engineering mechanics, we assume all the bodies are rigid bodies. The objective of this topic is to find the reaction force at the contact of two bodies. Next, action forces. It means it is the force exerted by the one body on the other. For example, weight force. We place the book on the table. So the weight force of the book is act on the table is called action force. Next, the reaction force. The reaction force is developed due to the Newton's third law. So every force there is always an equal and opposite reaction forces. Next, equilibrium equations. So equilibrium means the summation of all the forces that act on the body is equal to 0. Here equilibrium equations. So three-dimensional equilibrium equations. The first equation, summation of Fx equal to 0. That means in three-dimensional object, summation of all the force in x direction is equal to 0. Next equation, the summation of Fy equal to 0. That means the summation of all the force in y direction is equal to 0. Next, the third equation, summation of Fz is equal to 0. That means the sum of all the force in z direction is equal to 0. If a body, number of force act on it, then it satisfies the three equations. We say the body is in equilibrium. Next, free body diagram. The free body diagram means the body is free from its surrounding, or the separate from the system, and specify the all the known force, unknown force act on the body. The free body diagrams are very useful in engineering mechanics to solve the problem, or it is used to simplify the application of theory. Next, we are going to see the problem. A sphere of mass m rests in V groove, whose sides are inclined at an angle of alpha and beta to the horizontal. Another identical sphere of same mass rests on the first sphere and in contact with the side of incline at an angle of alpha. The reaction force on the lower sphere at the point P. So in the problem, V groove. In V groove, we place the two identical sphere. So identical sphere means the radius of sphere is same, R1 equal to R2, and the density of the sphere is same. So ρ1 equal to ρ2. So the same size and same weight of the material. So sphere of mass m rests in V groove, whose sides are inclined at angle of alpha and beta to the horizontal. That means we place the V groove on the surface. One side of the V groove surface is inclined at an angle alpha to the horizontal plane, and other side of the V groove inclined at an angle beta to the horizontal surface. Here the problem is to find the reaction forces at B. The reaction forces are developed due to the contact between the two bodies. The reaction force here, the body, we first consider the sphere 1. The sphere 1 contact the one side of the V groove at point B, and the same sphere contact the other side of the V groove at point A, and the sphere 1 sphere 2 are contact at a point C The next sphere 2 is contact to the one side of the V group at point D. Here the problem is, the objective of the problem is to find the reaction forces at point A, at point B, at point C and at point D. So we assume the system is in equilibrium. That means the total force act on the body is equal to 0. So we assume the system is in equilibrium. Next, we draw the free body diagram of the individual sphere. The bottom sphere is the one. Here, the sphere, bottom sphere is the sphere 1 and top sphere is the sphere 2. We first draw the free body diagram of the sphere 2. Sphere 2. So first is sphere 2. So here we use the idealization concept. We convert the sphere into the particle. So idealization concept. So here the point O2. The point O2, three forces are act on the point O2. O2 means the center of the top sphere. The first force, weight force. The weight of the force is act on the point O2. O2 means center of the sphere 2. O2. So through the center, the weight force is act on the body. The weight force is always vertical. Next, the reaction force are developed at the point D. So this means the RD means the reaction force. The V group, one side of the V group surface, apply the force on the sphere 2. Next, RC. RC means here. So the RD, the direction of the RD is always perpendicular to the point of contact between the two bodies. Here, this point D here, the surface sphere 2 and V group surface are contact point. Point D is the contact point. In contact point, the reaction force are developed perpendicular to the contact point. So the direction is here. And RC. RC means the reaction force. The reaction force developed by the sphere 1 on sphere 2. So here the direction. The direction of the reaction force. The direction of the reaction force is always perpendicular to the point of contact between the two spheres or two bodies. We place the coordinate system here. X-axis, this is x-axis, this is y-axis. In engineering mechanics, from first unit we learned we can orient the coordinate system at any angle. So it does not affect the result of the problem. That means we can place the coordinate system at any angle. So we place the here we place the coordinate system parallel to one of the surface of the V group. So here we place the x-axis, y-axis. So free body diagram of the sphere 2. We drew the first free body diagram of the sphere 2. So in sphere 2, the two force, the reaction force RC and D are unknown force. We can find the weight force by using the volume and density of the material. Here the angle alpha and beta. We can find the angles alpha and beta from the trigonometric concepts. So in next slide we are going to see how we put alpha and beta in the diagram. So for simply we just pre-assume the problem. Here point O2, three forces are act at the point. So we are going to find the two unknown forces RD and RC. So we can use Lami's theorem. Lami's theorem. In Lami's theorem, each force is proportional to sine of the angle between the other two forces. We use the law to solve the reaction forces. We use the law to solve the reaction forces RC and RD. So next this diagram means free body diagram of the sphere one. Previous slide here, free body diagram of the sphere one. We first identify the weight force. The weight of the sphere one is always acts through the center point or center of mass, through the center point of the sphere. So the vertical weight force is always perpendicular to the point of contact. Then the reaction force is developed at point A, and the reaction force is developed at point B, and the reaction force is developed at point C. So we idealize the sphere one to the particle, and we apply all the forces, all the forces act on the body. Here we use the trigonometric concept. We draw the two similar triangles, and we use the normal trigonometry to find the alpha and beta angles. Here 4 forces are act on the particle. Here we cannot use the Lami's theorem, because the Lami's theorem is applicable only 3 forces are acting at the point. Here 4 forces are acting at the point. So here we are going to find the reaction forces RB, RA. So 2 unknown forces, 2 known forces. Weight force M1 we can calculate from volume and density. So here RC force we calculated from the previous step. So here we apply the equilibrium equations. Here only 2 coordinate axes are here. So we use only two-dimensional equilibrium equation. The first one is summation of fx equal to 0. Second one is summation of fy equal to 0. We use the problem. So first case, for sphere 2 we apply the Lami's theorem. So RC is proportional to the sine of the angle between the other two forces. RD is proportional to sine of the angle between the other two forces. M2. So mass is proportional to weight of the mass is proportional to angle between the other two forces. We simplify the terms and find the RC and RD. Next here, sphere 1. Here more than 3 forces act on the sphere. So we apply the equilibrium equation. So first equation, summation of all the force Fx equal to 0. We add all the force in x direction and equal to 0. Then summation of Fy equal to 0. We add all the force in y direction equal to 0. We can find the RA value and RB value. So this is the concept, equilibrium concept. By using this concept, we can find the reaction force at the point of contact between the two bodies. Okay, thank you.